Okay, good morning. Welcome to
SuperMath number 13.
SuperMath number 13. So instead of doing a problem out of your book today, you had an AMC8 problem that gave you a little bit of trouble, and it's a geometry problem, so I thought it'd be a good geometry video. And we haven't talked about this other than you did it once and had trouble with it, so let's see if we can work through that trouble. How many isosceles triangles with integer side lengths have perimeter 23? Alright, tell me how you want to think about this problem.
Well, I'll find the largest one of this that fits its restraints.
Okay.
I think the largest one is going to be this one. 11, 11, 1.
Okay.
And then I'm going to keep going down until I hit the first one that doesn't work.
Okay.
So 10, 10, and 3. Nine, 9, and 5. Eight, 8, and 7. 7, 7, and 9. Yeah, this works. Six, 6, 11. The way I'll know if it doesn't work, actually, how many are, I think we can go down all the way down to 1, and it'll still work.
Well, let's see.
Well, 5 and 5, 13. This one doesn't work.
Okay. Here, let's try that bigger over here. So the old 5, 5, 13 triangle. Now, at first you thought you could go all the way down to 1, but then you said this 5, 5, 13 triangle does not work.
Well,
why doesn't it work?
Because this actually drawn correctly, this triangle would look more like that. Because this 10 doesn't stretch across 13.
Okay, the longest you could stretch out 5 and 5, it would be 10. So if you had a point here and a point here that were 13 apart, if you tried to go 5 that way and 5 that way, you'd never get, it wouldn't close the gap. Do you remember what that's called? That's an algebra/geometry thing.
I don't think so.
It's called the triangle inequality. And the reason it's called the triangle inequality is exactly because of this.
They're not equal.
Okay, so you don't form a triangle anymore. But your way of thinking about this problem, I don't know how you thought about it before, but your way of thinking about it now on the board is really good. Just here's an example that works. It works. It works. It works. It works. If you wanted to, you could at the beginning say, hey, I wonder if I can go all the way down to 1, in which case I would have this wonderful little isosceles triangle 1, 1, and what was it, 23? So 21.
But no, this does not work.
That seems pretty problematic, right? I've got
Yeah.
points that are 21 apart, and I've got...
So unless 21 equals 2, this isn't going to work.
Right, except in a world where 21 might equal 2. And in any case, so you figure out that this doesn't work, and you figure out that the 5, 5, 13 doesn't work. Does the 6, 6, 11 work?
Yeah, because 6 plus 6 is 12.
Okay, very good. So if this is 11, I can actually close the gap with 6 and 6 because it adds up to 12. It'll be very skinny,
Yeah,
but it does still form a triangle. So what is the answer? How many of these triangles are there?
There's 6.
There's 6. All right. Good job. Good job.